So we are on remainder theorem. Remainder theorem states that if f is a polynomial function and it is divided by x minus c, then the remainder is fc. So whenever you're asked to divide a polynomial by a linear polynomial, the answer is the constant here, fc. So let's prove it. So if you have p of x and d of x are polynomials with d of x, x minus c, then there exists a unique polynomial qs and r such that this is just to tell us, whenever you're asked to divide something by, example, let me use the example. If you have 17 divided by 5, this 17 is the dividend, while 5 is the divisor. So that's what we are telling us. If p of x is the dividend and d of x is the divisor, so we know if you divide this, we have 3 whole number 2 over 5. Yes, this 3 is now the quotient. 3 is the quotient and 2 is the remainder. So that's what they are trying to tell us, that 17 is now equal to 5 times what? 3 plus 2. So do you see it? P of x is our dividend, 5 is the divisor, 3 is the quotient, and the remainder. So if you have a polynomial, it's always like this. If you are dividing a polynomial by another polynomial, but in this case, the polynomial, that's the divisor, must be a linear factor. That is a polynomial of degree 1. So that if you have anything like that, the answer is f of c, the constant. So to prove that, we've known this from the basic. So what do? If you substitute x as c, that's our q of x. So remember, our divisor is x minus c. So if you substitute, this is the divisor, while this is the quotient. So though I interchange it so that it will look reasonable. So c minus c is 0, and 0 times that is 0. So you see that the remainder r, that's what is left. So r is now is the same thing as substituting x as c. So let me use the example to show you what I'm talking about. So if you're asked to find the remainder if this f of x is divided by this, so it's very simple. So for the first one, so they gave us f of x to be that. So if we now substitute for this, that is, if f minus 1 equal to 0 implies that x is 1. So if you now substitute x as 1, you see that we have 2 times what? 1 cube minus 1 squared minus 3 times 1 plus 6. So we have 2 minus 1 minus 3 plus 6, which is, this is 1 minus 2, 4. So you see that the remainder that you get by dividing this by x minus 1 is 4. So that's the advantage of remainder theorem. You don't need to waste time using long division. So why this one? The same thing. If 2x minus 1 is 0, that's making x the subject of formula. X is half. Therefore, f of half is now, we substitute 1 over 2 cube minus 1 over 2 squared minus 3 times 1 over 2 plus 6. So this is 2 times 1 over 8 minus 1 over 4 minus 3 over 2 plus 6, which is, this is 1 over 4. 1 over 4 minus 1 over 4 is 0. So we are left with minus 3 over 2, that is, let me write 6 minus 3 over 2 so that it will be easier. So this is 12 minus 3. 12 minus 3 is 9, so 9 over 2. So that's it. The remainder is 9 over 2. So that's what remainder theorem is talking about. That instead of wasting time, just substitute. As long as the divisor is a linear factor, as a polynomial of degree 1. So thank you.